taking some brief notes on rigid transformations. And a lot of this content is actually review from middle school if you're in like a high school geometry class. But it's helpful to kind of go back and refresh on these ideas. And all we're doing throughout these notes is kind of filling in these boxes for various examples. And then through some lessons in class as well as digital practice online, you'll have some more advanced versions of those things. All right, so this first one, what you will see is there are 3 columns. And let's go ahead and I think I can freeze this column pin header row. Yeah, so I can keep that column or that row across all the pages. And what you're going to be looking at for some of these examples is sometimes it'll have a black and a blue triangle, and that means we need to fill in what the description is of what's happening, but also the math notation. But in some other ones, the notation will already be given to us. And if that's the case, then we have to draw let's say a blue triangle. We'll keep it consistent for the notes. And for every single one of these, we want to give a more common language description of what's going on. So just explain in words what is actually happening, not just the very abbreviated math notation, but a little bit more words. So if we come back and read it, we can make sense of it. So let's look at this first one. I'm actually going to zoom in on the picture here. And I noticed that there is what's called a pre-image, this black part here, and a image, which is like the projection of the pre-image. It gets projected somewhere else. And I noticed that these two are the same, and that's what happens with the type of transformations that we're looking at today. But then my questions are like, how are they the same? Well, I also noticed that you can kind of trace the start and finish of each of these lines. So if I were to go from I to I, J to J, and K to K, I have those 3 lines, and it looks like every single one of those lines is sliding. And that's kind of a key move there. So if it's sliding or kind of moving, but not twisting, no spins, no flips, nothing like that, then we call it a translation. Now I'm going to highlight each of these lines so they stand out just that much more when we look at things. And we'll make them thicker, and let's say dashed to kind of imply like the movement. And I'm not drawing a 3D shape here, I'm just showing that it moved in a certain direction. Now what I'm also going to do is draw some lines. Oh, you know what? Here, for each of those lines, let's say that we have these arrows that kind of imply the direction. I'm also going to draw a couple of lines that trace out the movement, broken down into a vertical and a horizontal movement. So we'll make this movement with an arrow, and then this movement with an arrow that way. So it looks like we went 3 up and 3 right. So we are going to say slide 3 units up and 3 units right. Okay, so what do we mean by that in the math world? That's called a translation. And the translation we define kind of like as a XY movement. So in the X direction, it's actually the same for both. So in the X direction, it's 3, and in the Y direction, it's also 3, meaning that it was positive 3 and positive 3. Now for this next one, hopefully we have a little bit more kind of change to it. All right, so now this is a little bit different because we went up and right. Now we're going down and left. How do I know that? Well, let's go in here, change this arrow, make it a little bit thicker. I start at S and I end at S prime. Whenever you see that little apostrophe, we call that prime. And we'll make this dash to kind of show the movement, and I start at R and go to R prime, and I start at T and go to T prime. So each of those is going down and to the left. So let's think about the X direction here. So we got 4 units left and 3 units down. How do I know that? I'm just counting these spaces here. So 1, 2, 3, 4, 1, 2, 3. Okay, now let's talk about that movement in terms of words and math. So the words, it says it slides 4 units left and 3 units down. And just for consistency, I'm going to switch this up and right. I'm going to say right and up. Why? Just because we have like the X number first and the Y number second. So we're doing a translation. It is 4 units left. Now, when we move left on a graph, we call that a negative direction. So that's going to be -4 for left. And down is also negative, so that's going to be -3. Okay, now we want translation of 6 left and 5 up. So I'm gonna say that in words here before I actually go into my drawing, just so I have an idea of what I'm going to be doing. Slides 6 units left and 5 units up. Remember that the first number is your horizontal and the second number is your vertical. Like X is first, Y is second. So 6 units left, 5 units right. If I go into this drawing, one of the tools that is going to be very useful for these transformations is to click on polyline here. So I'm going to click now on the corners of these triangles, the vertices. 1 and then 2 and then 3 and then close it off back at the beginning. Now it's not exact, like you could probably find a gap where it's slightly different in its overlap, but it's close enough, and that's what we're aiming for. So I want to now take this and I want to do a couple of things with it. Well, I could have just taken a picture of it too. That's something I could have done. But I want to move it 6 units left and 5 units up. That's what it had said before. So 6 units left is going to be 1, 2, 3, 4, 5, 6, all the way at the edge. So this would be 6 units left. Then we got to go 5 units up. 1, 2, 3, 4, 5. So that would be there. Now, a couple of ways that I can kind of think about that too is that R was at 1, so -6 from 1 for the X direction is going to be -5. 1 minus 6 is -5, and this is where -5 is. Similarly, 5 units up means I'm going to go back to 0 and then up 3. So that R is now at -5, +3. -5 for X and +3 for Y. Now here's another way that you can do this, probably going to be more popular in these notes, and I think that's great, is to take a snapshot but include the letters and everything in it and make it just big enough. And if I were you, I would include the squares, try to get it right on that grid, kind of as close as you can. It'll make it easier for the movement. So I'm going to capture that and then I will paste it using my keyboard shortcut. Now I got to resize it so that it fits right on top of where it was. It's got to fit right in here. So there's that. Okay, now it's almost like you can't even notice that it was there. But I'm going to click on the pencil, put like a red outline around this, make it a little bit thicker, so I can see where that rectangle is. Now I got to move this rectangle 6 units to the right, which means it actually goes to about here, where this little piece you could say it's off the grid, and then 5 units up. So 5 units up, if I'm just looking at this red corner of the red grid, I'm going to go 1, 2, 3, 4, 5. So it's going to be all the way up there. And that's another way to try and visualize what was going on. And if I want to, I could trace, instead of the polyline, I could go back, I could use this arrow tool and say from S to S, from R to R, and from T to T. There we go. So that's that transformation in action. Okay. Now, let's see what we can do with some other things. We have another one, translation 3-2. So that means it's going to slide 3 units left and 2 units up. I think I'm going to do that same thing where I just screen capture and paste it right on top of itself. So I'm going to try and include all the letters in here, which means I'm taking a grid slightly bigger than the triangle itself, so it kind of includes all the letters. Again, I like having it where it hits right on those edges, makes it easy to line up later. Capture that, paste it. Now I gotta line it up. So I had it here, and let's see, is that what we want? Here, I'll cut it and then paste it again. Yep, those are right on top of each other. I'm going to outline this, make that outline nice and thick so we see what we're doing. I forgot the movement, so let's go back and check. 3 units up, 3 units left, 2 units, 3 units right. If we're in the positive direction, that means we're going 3 units right. So I'm going to go 3 units right. There's 1, 2, 3, and then 2 units up. There's 1 and 1 more. Kind of have to nudge it a little bit. If you're trying to nudge more precisely on a keyboard, a helpful move is to hold down the Shift key, and it lets you do more precise or more fine movements instead of larger jumps. Okay, now here's something interesting. It's hard to tell just because these have a weird overlap with this big giant space here, if we're doing that exactly right. So once I have an image there, I'm actually going to go into the format options of that image. Oh, it's not going to let me. I thought it would. So if this were just any kind of image in Google Docs, we could actually make it semi-transparent. And we could crop it to be exactly around it, but we're gonna leave it as is for now. And one way that I can kind of confirm again is if I do an arrow and I can say it looks like we're doing 3 units to the right and 2 units up. C is also doing that. And if I were to take out B and figure out where it is, it looks like it's here. That's still 3 units up, or 3 units right and 2 units up. So there we go. All right, now let's do some different ones. Okay, this one is very different because even though it looks like it moved, it didn't slide. It kind of swapped some directions because over here E is on the left and F is on the right. On the other side, F is on the left and E is on the right. Similarly with D and G, those kind of change directions. And if you're not sure which one is G and which one's G prime, we have some coloration going on there. Well, this is what is called a reflection. And we're going to kind of draw the mirror line to show exactly where that symmetry is that cuts these two things in half. You might not notice that we drew a line there, so we're going to make it extra thick, and we'll color it some bright contrasting color like red. So that red line there is the mirror line or the reflection line. So this is a reflection, and it's across, now here's an interesting kind of thing. We would call this the y-axis, right? But another way to define that is across x equals 0. Now let's talk about that just for a moment. This is kind of reminding us a little bit of some graphing things. If I were to move this line here, this is at x equals 1. This is at x equals 2 because I go to x, and all of these things up and down this line are at x equals 2. Similarly, that's at x equals 3, x equals -1, x equals -2, and here is x equals 0. Okay. Now, if you're still not sure of kind of what I'm saying there, let's see if we can redraw this in Desmos just for a moment, and you'll be able to tell from there. So let's do desmos.com/geometry calculator, and we are going to turn on the grid and the axes, and then we're going to do that shape. This shape goes down 4, and then F right there is at -3. So this shape is created by, there we go, this here. So we're gonna go 4, 3, there we go. And I think that's it. That should be the shape. And this shape is then reflected, so that there's a transform button in the geometry tool, and we're going to reflect this, but we need a line to reflect across. So I don't have a line yet, unless I wanted to reflect it on itself. So I'm just going to put in a line here, x equals 0, right? And we could even say x equals a, and a equals 0. And we could slide this back and forth. Do you see that? So when I slide this to like 2, x equals 2 there. Okay? So we're going to reflect over that line. I'll click on my shape, transform, reflect, and then we're going to go across that line. Did it work? No, I don't think it did. So transform, we want to reflect. Oh, I need a line segment. So I got to draw an object in here, or some kind of line. There we go. Now it should accept it. So we're going to transform, reflect that across that line there. Okay, cool. So now this is exactly what our picture looks like. But if we were to adjust this line over here, notice that the reflection doesn't line up in the same way. So it's lining up right on that line in the middle that is x equals 0. So there we go. We get the same shape. That was just a little bit longer explanation showing a tool that we could use, because that tool is actually going to be useful looking at this next one. So now, ooh, this one wasn't a drawing, but that's an easy fix. It will be fixed for your notes. Go and edit here. What I'm looking for is a line that splits this picture symmetrically, and I believe the line is there. We'll make it nice and thick, color it red so we can see that very clearly, kind of the reflection going on. Now for this line, it's going to be y equals a number. So we're going to say it's a reflection across y equals, and then what is this y value? What is this height across that red line? And that height is 3. Okay, so let's talk about how would we describe these things. Another way you could describe it, reflection is a great word, but you could say flip over the line x equals 0, or the y-axis. Okay, and then this next one we'll say flip over the line y equals 3. Now I'm going to add a couple of description words in here. What kind of line would we call the x equals versus the y equals? Well, we would call the x equals a vertical line, and we would call the y equals a horizontal line. And that's just helpful in trying to connect, like, okay, when it's horizontal, it's y equals a number. When it's vertical, it's x equals a number. Okay. Now let's do just a quick reflection here where it's going to say reflection across the x-axis or y equals 0. So we want to take this shape and reflect it across the x-axis. Okay, we could do that. So I'm going to do the screen capture that we did before. I'm going to try my best to line things up with at least some of the grid boxes, even though these go a little bit off the page. You know what, let's do this. Let's lock in right on the shape. Let's get nice and close to it. And that might be helpful so we don't have any weird overlaps. Okay, so I'm gonna copy and paste that. But before I paste it, I am gonna mark where that x-axis is. The x-axis is here it's this midline horizontal going across. Again, you can't see that line unless we make it nice and bold, both in size and color. And we've copied that shape so I can paste it. I'm going to line it back up right on top of itself. And that looks pretty good. So what I want to do now is reflect it over this line. Okay, so if I want to reflect, I'm going to right click on it, and it's actually under the rotate menu, which is not necessarily the obvious place, but we're going to flip it vertically, and that means that it flips up and down here. And notice kind of how I located it. I have 2 units on the distance to the reflection line here and 2 units on the reflection line there. So it splits that distance equally on both sides. And then for the other point, the I point, it's got 3 units and 3 units. And of course, since I copy and pasted the picture itself, the K should line up no problem. From K to the red line is 5 units on one side and 5 units on the other. Okay, and so we are going to flip over the horizontal line y equals 0, or the x-axis. Okay, now we're going to get into kind of our final set of things, some rotations. Rotations, rotations, rotations. Let's see what happens with them. So for this first one, well, how do I know it's a rotation? Let's look at the picture more closely. When I see this picture, I notice that it looks like it's facing opposite directions, but not just opposite left and right, it's also opposite left and down. You could say it's like it did a double reflection. And in fact, a rotation does kind of, represent a double reflection. So what I'm looking to do is, how can I get these things to all line up? Well, let's show one thing real quick. I'm going to show a circle that will line up some of these points. So if I line up, let's see, there, and I'm going to remove the fill. You don't have to necessarily draw the circle. I just find it helpful when trying to visualize some of these things. So notice that the L's line up on top of each other. I'm going to copy and paste that and make another one, and show where the K's line up with each other. Whoops, I got to keep them concentric or kind of centered all at the same place. So now the K's line up with each other, and then we'll copy and paste again, line those up, make them concentric, and then we can line up the M, and then copy and paste, and we will make these concentric as well. All right, so if you notice the ends, let's see if we can color these, like maybe various colors to show where they're lining up. We got a green, a blue. The outer one we'll make like a pink. And I'm going to make that go down a little bit so I can get to this one. And we'll make this one a orange. So the L is on the orange circle in both cases. And notice whenever you have these circular paths and the points all line up on those, the center of all those circles is our center of rotation. And that's how those two pieces are going to rotate into each other. So I'm actually going to make this go side by side. We'll see what's happening. Move this over to the left. Perfect. Oh, we got to save this first and then reopen it. There we go. So what I'm looking to replicate is that same graph here. So I'll zoom in a little bit. And we're just going to start over on this page. I'm going to put on my grid and my axes so I see where I'm at. I'm going to turn off the minor grid lines so I can specifically know that I'm on that like -5 to 5 kind of place. All right, now let's trace this. This is at -4. If I'm going K, L, M, N. So K is at -4, -3. And then it goes up 2 units to make L, and then over, right 2 units, right 1 unit to make M, and down 1 unit here, and then over there. Cool. So now what I can do with this shape is I can drop a point for my center there in the middle, and I can see how much I need to rotate it by. So I'm going to click on the shape, click on transform, and then rotate. And I'm going to try to rotate it, see how far it's going to go. But it first asks me, where's the center? Well, I'm going to use 0, 0 as my center. And I could try 90 degrees, but that only does it to there. So I'm going to delete that. I'm going to try again now, and I'm going to transform. But instead of this, I'm going to transform. Let's try this again. Transform, rotate this by 180. Let's see what that does. Okay, so 180 is the winner. Notice how those line up there. 90 degrees only goes here. I'll color that maybe green. And this one, we'll color this original one black to kind of match what we have going on there. So the green was 90 degrees, the blue was 180 degrees. And that matches what we wanted. Cool. So it was a 180 degree rotation around 0, 0. So we have a rotation of 180 degrees centered at 0, 0. Awesome. I'm going to leave this over here on the right so we can kind of reshape and see some of the other things that might be happening. Now this one looks like it's also going to be a rotation, but it's kind of different. It's like it's facing up and then it's facing right. So it looks like a rotation that's happening like this, like it's kind of going up and then spinning over that way. So it's doing that kind of thing instead. So it's doing a 90 degree rotation, just a quarter turn. Okay, well, I'll delete that. Let's see if I can replicate what's going on over here. So for my black one, I have a point here at -5, -1. I have a point at 1, -3. Try and lock that in. I have a point at 0, 0. And a point at -3, 4. Is that 4? Yes. All right. Now things are almost lining up, but I don't think I have the rotation that I want. I don't have this one in the top right corner. So I'm going to delete this one, delete this one. Let's try rotating clockwise. Now, when you rotate clockwise in a math world, that means that it's going to be a negative. So this is kind of weird. Math rotates counterclockwise as positive and clockwise as negative. And that's hard for us to intuit or to kind of think about in a obvious way, because we read clocks and clocks rotate one direction, and we always think of the default as being positive. But clocks actually rotate in a counterclockwise direction. Now it looks like we have a match, so that's good. That's good. Awesome. So I'm going to save and close. I could have drawn the circle with the rotations on each of these. In fact, I'll do that real quick. And if you want, you could just screenshot from my screen to kind of help with that. So what you might not notice is a way that I do that, and I'll start with the X1 here, is I hold down Shift to make a circle instead of just any kind of ellipse. So I do that, but I also try to center it at 0. So I'm going to nudge this over just slightly, keep it right at 0. And then if I do Shift and I believe it's Alt, I can stretch that circle while keeping it at the same center. Those are keyboard shortcuts that are helpful. So now the X's line up. We'll color that our orange circle there. I'm going to copy and paste it. And when I do that, I can tap the arrows up, up, left, left to line them up again. And then Shift and Alt allows me to make it bigger. I'll go to the next letter. It looks like U and V are right on top of each other. So that's kind of neat. So the U lines up with the U and the V lines up with the V. And we'll make that a slightly different color there, this hot pink. So that's one way to show that rotation going on. So we have a rotation, and it's of 90 degrees, but we're going to put a negative sign in front of it. Or we could say 90 degrees clockwise and centered at 0, 0. All of these are being centered at 0, 0. That's actually just an easier version of the transformations. Otherwise, we would have a translation combined into it. But we'll get to that in later versions of this in the second semester. All right, now I'm going to go in and do what this thing says, but I'm going to draw it on this picture. So let's try and do that. So I see this picture here. I'll go ahead and screen capture this triangle. I'll get it nice and tight on it. Line it up with those edges. Perfect. I'll capture it. Now I'm going to paste it back on. Line it back up, make sure the size is the same as it was. It looks the same, which is nice. And now I need to rotate it. It's at 180 degrees around this center point. Well, I can say rotate, and it only gives me 90, so I got to do that twice. And when it rotates, it kind of rotates in place, but I want to rotate it so that it's centered here. So if it's centered there, I could imagine a circle going through the H and hitting all these corners. So let's see if I can draw that circle. Get it centered there. Turn off the transparency. I'm going to do Shift and Alt, so now I can stretch this and line those up. And those do look lined up now that it's hitting both those corners. I'll copy and paste that same circle and stretch it through the G point, and it looks like those line up pretty well. This picture might be just slightly off in its location and its sizing, even though it's very close. There we go. Now those are lining up very nicely. And then I'll copy and paste this last one and line it up here. Perfect. So I have those three things lining up, and it's 180 degrees, which means it kind of jumped two of these quarter sections. That's one way to think of 180, is a quarter turn and a quarter turn together make a half turn for that piece. Okay, now we're going to do this last one and then be done. So I'm going to take a picture. It said to rotate this one 90 degrees clockwise. So we're going to do that kind of quickly. I'm going to capture this one and paste it right back on top of itself. But I want to make sure that we're lining up with the same size boxes and everything. Now, a quarter turn means I'm going to rotate, it said clockwise, but I have to put it somewhere over here. Now, here's another way to think of these kind of ways of how do I know where to put it. Well, T is 3 units from the middle, so that same point, which is this point right there, is going to be 3 units from the middle, but up. And now everything should be lined up. So let's confirm it with some circles. So I'll make a circle for that inside. Line it up with the T and make it transparent. Perfect. And then I can copy and paste it. Maybe I can line up the V or the U. It's going to go a little bit off grid, but that's okay. Yep, the V lines up there pretty well, and the U would be the same. So I'm going to copy and paste, put it back, and line this up there. So the U lines up on that outside edge, the V lines up there, and the T lines up there. So our rotation circles work well for showing that. And again, feel free to kind of copy and paste my picture to help show that as well. All right, so we're going to say this is like a turn or a spin, but we're going to say it's 1/4 circle around the middle, the 0, 0. So we're going to copy and paste that because that's kind of the same thing that's happening in all of these. It's just whether it's a turn of a half circle or a quarter circle. So the 180 is a half, and 90 is a half circle clockwise. Or, yeah, so that one was clockwise, and this one was a half circle. There we go. So, and this one was also clockwise. So remember that 90 degrees clockwise on a math calculator tool, like the Geometry Desmos tool, is going to actually be a negative number. Negative for clockwise, positive for counterclockwise. And we will finish it there.